Let's talk about this. It's a United Airlines Boeing 737 MAX hit by suspected space debris midair at 36,000 feet. As of right now, it's pretty unclear as to what exactly hit this airplane. It could have been a meteor or meteorite. I'm actually not sure which is which in this particular case, or it could have been a satellite. But I thought now is actually a really good time to talk about what could be an impending disaster for humankind, and that is Kessler syndrome. So let's take a step back and talk about what space debris is. In particular, we're going to talk about satellites. See, we live on a ball in space that we call Earth, and because we like balls so much, we send a whole bunch of itty-bitty balls into space, and we call those balls satellites. Now, these satellites will do different things depending on where they exist outside of the Earth's atmosphere. Some satellites are super far away in geostationary orbit so that they can pinpoint an exact location on the planet, and they maintain that position as the Earth rotates around. The majority of satellites, though, end up being in this region down here called low Earth orbit. That's where a lot of the commercial utility is. Now, when you send satellites up into space, they necessarily must come with deorbiting plans. That is to say, ways in which we plan to get that satellite out of the low Earth orbit zone. One such way is to kick the satellite basically as far out away from the Earth's influence as possible, which will make sure it doesn't really hit anything of any importance. But there's still two different ways to deal with the satellite. One of which is actually to send the satellite to a place known as the Satellite Cemetery, right around Point Nemo, which is the furthest point away from basically anything living on the planet. It's literally the least hospitable place on Earth for life, and because the ocean around that area is so high in oxygen, basically nothing can live there. Now, if you don't send the satellite out and you don't send it in to Point Nemo, then you basically have one option left, and that is to let the satellite enter Earth's atmosphere in such a way that it is intended to burn up. The majority of satellites in low Earth orbit are such satellites. They're small enough that Earth's atmosphere should, in principle, burn them up. But there is one problem. Let me show you the satellites that are currently in orbit around the Earth right now. There are a lot of them, right? And seeing as there are a lot of satellites in space, there is a high chance of some form of collision. And when you have a collision, multiple things could happen, right? You could have the situation where the two satellites merge together into one big satellite. Or you could have the situation where the two satellites run into each other and then create a bunch of small little itty-bitty space debris that floats around the Earth. Now, in that case, you no longer have two satellites you have to track. Now you have potentially thousands of smaller satellites you need to track. And all of these smaller satellites could, in principle, cause more collisions. And those collisions could, in turn, create more collisions and more collisions and more collisions. And this runaway catastrophe is known as Kessler syndrome. Just to show you how much space debris is currently in the atmosphere, let me go ahead and click this debris box. And you'll see, actually, a lot of what is orbiting the planet right now is actually space debris. It's a bunch of junk that's just floating around in space, and we don't really have anything that we can do with it. Just to point out the obvious here, this is all the space debris and satellites that we are currently tracking, and it's basically impossible to keep track of everything, especially as we start adding more and more satellites into space. For example, here is just a quick visualization of the active Starlink satellites that are in the air. Moreover, on this same page, if we scroll down, we actually see a view of leftover debris from a 2009 collision. That's, 15 years ago now, right? Now, to make matters worse, of the 11,370 satellites that have been placed in orbit, 60% are still in orbit, and only 35% are still operational. So 60% are still orbit, and only 35% are still operational. That leaves a lot of just random space junk floating around as active shrapnel that could destroy another satellite, that could cause a cascading effect, that could do anything. We don't know, right? Now, look, I know I'm painting a really scary picture here. We've got a whole bunch of satellites in space, and they're going to collide, maybe fall down onto Earth and kill somebody, right? And we saw what potentially could be a glimpse as to what could happen in the future with this Boeing flight. All things considered, that's not the most likely case. The most likely case is that we see these satellites start to ram into each other again and again and again and again, and eventually they create basically a dust that exists outside of the Earth, where, because of the collisions, most of the satellites will enter Earth's atmosphere without harming anyone. They'll just burn up, right? Meanwhile, if we, as ball lovers, or whatever I called us before, want to send more of our little itty-bitty satellites into space, well, we're going to have some issues, because we have essentially a layer of sandpaper that exists outside of the planet. And it's going to be very difficult to send basically anything past that layer of sandpaper, right? So basically all things that rely on satellite systems have a potential of going down. Maybe because we have to maintain like a geostationary orbit satellite and we just can't get there because it's very hard to send a satellite out there. Or maybe the system is actually reliant on low Earth orbit and it's just too cluttered in that area to send a satellite out to begin with. My guess is that if nothing is done about this problem in the long-term future, we're going to deal with satellite brownouts, which could be a big problem. That said, nobody actually knows the future, and it's entirely possible that two satellites collide, create a megasatellite, and that megasatellite falls onto something on Earth, creating massive damage, right? That is entirely possible. We don't know. Now, there are some people who have estimated the number of people who will die due to space debris this century. That's impossible to actually claim. Though we have a good track of the satellites around Earth, we don't have a great track of it. So there really is no way to simulate what is going to happen in the next 100 years here. It's like a weather simulation or climate simulation. These things are probabilistic at best. But I'm hoping that this little bit of space debris that hit the Boeing 737 acts as a wake-up call to, I don't know, legislators around the world to enforce more regulation about deorbiting satellites in space. But even if we have legislation about orbiting and deorbiting satellites, this doesn't solve the problem that we still have a lot of junk up there that we have to get rid of. And though people are currently coming up with plans in order to remove this junk from space, there isn't currently a widely accepted way to do this. So now we're at that boundary of human knowledge, of all the things we know and we don't know about this topic. We know there's a lot of junk in space. We know we need to stop putting that junk in space, but we don't know how to get the junk down, and we don't know exactly what's going to happen and when. So we need researchers like you and potentially myself to come in and start figuring out how to deal with these problems. We've got to deorbit satellites. We've got to figure out how to properly simulate this in the future so we can figure out what will be damaged, when it will be damaged, and how to mitigate that damage in the future. I mean, if I just go to Google Scholar right now and I look up Kessler syndrome, right, we're going to find a whole bunch of papers, some of them from back in like 1970, which is when this was originally proposed, right? And importantly, we've got papers this year talking about not only policy, but simulation methods, everything, right? This is actually a very active field of research, and it's something that we have control over. Just like almost every other issue that has faced humanity, we as humans kind of maybe caused it, and we as humans probably can fix it, right? So we're kind of at that tipping point with space junk as well. We have a lot of ideas and ways in which we could progress in the future. We just have to figure out the best way to do it and go from there. And we have to make sure that everyone's on board so that we can actually start tackling this problem and make sure that no one actually dies because of random satellites stuck in space. Or rather, satellites as they come down. If you're interested, go to Discord. There's a link in the description. I've actually had my eye on Kessler syndrome simulations for a long time now, and there's a lot of different things that I feel like we could do in order to advance the field, and it's always really interesting when we find areas of public interest that are also interesting research areas that we can push. As always, it's a little bit gray. Yeah, we had a piece of space debris hit an airplane, which is scary, and it's even scarier knowing that more of this is probably going to happen in the future. But on the other hand, we have plenty of ideas on how to fix this. We just have to start mobilizing and solving the problem. At the end of the day, I have full faith that, like everything else, the solution to this will be obvious in hindsight. It's just that you don't have the advantage of hindsight when the events haven't happened yet. So, we'll see if this becomes another climate change. Yeah, that's a sad thought to end it on. Bye.